Welcome to our field trip investigation, and here's our group members, Snow, Anna, Jacky, and Bob. And here's some brief description about Nam-Cat-Ding. Cat-Ding Nation Park is a forest containing valuable biodiversity resources that is unique to Vietnam. Recently, on the World Tourist Day on September 27, 2012, the government of Vietnam ranked it as a Ramsar site of international importance. Cat Ding Nation Park is a special national relic.
The purpose of this experience is to collect standardized data at a location surveyed by vast distance, then comparing the data to determine. To do this experiment, we need a string for zoning and creating a quadret, a pen, and notebook for recording data. For wooden stick, a glue gun, and a copper wire for creating a quadret. We wouldn't for summing. On left is our picture we shot, and on the right are image of species record. In quadrat 1, also known as symbol 1, has three types of species such as black ant, grasshopper, and spider. Quadrat 2 has black ant and grasshopper. Quadrat 3 has four types of species: black ant, spider, grasshopper, and snails. And quadrat 4 has only black ants. And this is the result. In the first sample, the total number of species is 13 with the diversity index of 1.7. The second has a total of 7 with the index of 2.3. The third sample is only 11 and the index is 3.93. And in the last sample is only one species with a total of 12, so the index is only 1. Here is the percentage of species occurrence. Sample 1 has 48%, sample 2 has 20%, sample 3 has 52%, and sample 4 has 32%. After all, we have to analyze the calculation, conclusion, and record some errors. For analyze the calculation, in quadrat 1, the population of black ants is the highest, just a few grasshopper and a spider. But in quadrat 2, the population of grasshopper is higher than of black ants. The quadrat 3 living species are abundant with black ants, snail, spider, and grasshopper, but opposite with quadrat 3 is only black ant in quadrat 4. For the conclusion, we can see the soil in this area is dry and difficult to live, and just a few species surviving in this area. For errors, we will make some mistakes during this experiment, such as location and counting species. For the location, is good, but it's had less species and the soil too hot. And the actual number of species may be wrong because some hide under the leaf and species are constantly moving. So we need to estimate the number.
To turbidity, flow velocity, DO, and pH. First of all is turbidity. Turbidity is caused by particles suspended or dissolved in water that scatter light, making the water appear cloudy or murky. So how to measure it? There are several ways that you can measure turbidity in water, but using a statute disk is the best way and the most easiest way. The purpose of using a statute disk is to measure the turbidity of the water. In this project, we'll measure the turbidity in Nam-Cat-Ding River by using a statute disk. Coming in with the result for using a statute disk to measure the turbidity in Nam-Cat-Ding River. We test out 3 places in the same river since we want to get the most accurate result for turbidity. So coming up with the first trials, 30 centimeters is the first point in the statute disk test where the disk can't see anymore, and 15 centimeters is how far down we can see the disk again. We take measurements more than once to make sure that the data is correct. So coming up with the second trial is that the discs were unable to see at 19.6 centimeters and the discs were able to see at 15 centimeters. And third trials is that discs were unable to see at 18.2 centimeters and the discs were able to see at 15 centimeters. So let's calculate the average of the turbidity. Average of the low turbidity is 15 plus 15 plus 15 divided by 3 equal to 15 centimeters, and the average of the high turbidity is 30 plus 19.6 plus 18.2 divided by 3 is 22.6 centimeters. Deeper into the turbidity of Namkatin by observing. So in front of you is a turbidity chart from 1 to 10. It will indicate that either the water is healthy or not. On your right side, there's a picture of Namkatin River. According to the water that we can observe on the right side, the turbidity range of it is around 4 to 5 pH, which the water have started to have some sign in losing oxygens. Hence, it will affect the survival ability of aquatic organism due to lack of oxygens and suffer stunted growth. Lower turbidity is often associated with cleaner, but not always healthier water. Since turbidity varies across various kinds of habitat, is it particularly helpful for comparing comparable environments or the same water body across time? Coming with the conclusions for turbidity, when we use ESS Dp1 to measure water clarity, the ESS Dp1 in black and white provide the maximum contrast regardless of the color of the light transmitted by the leg, which means the result is really accurate after repeated measurements. The place that have the longest centimeters until the disc is unable to see is the place that have less turbidity in the Namkatin River. DL stands for dissolved oxygens. The amount of dissolved oxygens in a stream or lake can tell us a lot about its water quality. For DL saturation's result, our result for first trial is 80%, second trial is 83%, third trial is 82.6%. Dissolved oxygens in Namkatin is 4 ppm. 4 ppm in the river for the fish is not good. Fish require a DL level between 5 and 6 parts per million, such as ppm, to grow and survive. If dissolved oxygen's level decreases to about 3 to 4 milligrams per liter, even the strongest fish in the streams or lake may suffocate. Because of the turbidity, it may affect on the dissolved oxygens in the river. As conclude, when dissolved oxygens become too low, fish and other aquatic organisms cannot survive. Next, continue with pH. The material that we needed in order to measure the pH level in Namkatin River is pH-EP, pH pocket tester. So pH stands for potential hydrogens. The pH can control the availability of nutrients, biological functions, microbial activities, and the behavior of chemicals. The result that we collect from Namkatin River for pH level is that our first trial is 10. This is weak base alkali. Our second trial is 9.5. It's same as the first weak base alkali. Trial 3 is 10.4. So then we calculate the average pH in Namkatin River. We take 10 plus 9.5 plus 10.4 and divide by 3. The answer is 9.93. This is also weak base alkali. pH of 7 is neutral. pH of 8 to 10 is weak base alkali, and pH of 11 to 14 is strong base alkali. Fish have an average blood pH of 7.4, so pond water with a close pH to this optimum. An acceptable range should be 6.5 to 9.0. Fish can become stressed in water with a pH ranging from 4 to 6.5 and 9.0 to 11.0. Because of this, fish in Namkatin River are unable to live in the river. The average of the Namkatin River is 9.93, while the fish can only survive between 6.5 and 9.0. Continue with flow velocity. The velocity of a river is the speed at which water flows along it. The material needed for this experiment is an orange and tape measure. The purpose for this is flow rates measurements help us to control and monitor the rate of liquid flow within applications and ensure that fluid control processes are running safely and cost effectively. Our team used an orange to measure the flow velocity of Namkatin River. The distance that we're going to measure is 2 meters. The result for our first trial is 6 seconds, and other seconds trials and third trial 7 seconds. So now we take 200 centimeters divided by 6 seconds, and the result is 33.3 centimeter per second is the result for first trial. Second trials and third trial, we take 200 centimeters divided by 7 seconds equal 28.57 centimeter per second. So now let's calculate the average velocity of Namkhatin River by taking 33.3 plus 28.757 plus 28.57 and divide by 3. We'll get the final result for the average velocity in Namkhatin River is 30.15 centimeter per second.
Now we're going to be looking at the terrestrial ecosystem, which includes temperature and wind speeds. The purpose of understanding wind speeds can help us pinpoint and find exact locations of air pollution sources, which in turn allows us to have more in-depth knowledge on the status of the weather. Here to the left, you can see the wind speed results that has been taken at the resort, and to the right is the wind speed results taken at the creek. Next up is temperature in Namkhatin. Knowing the temperature is important when learning about a certain environment. Similarly to wind speed, we can see and study the weather patterns of that environment. Temperature also causes winds, so we can also use temperature data to predict wind speeds data. Here you can see the 4 trials of water temperature that we have taken. Alright, result analysis. The first and fourth trial had a temperature of 27.5 degrees Celsius, and the second and third had 27.4, which gave us an average of 27.45 degrees Celsius. We can see the temperature data here is very consistent with very similar results. So as seen in the results, the wind speed at the creek averages about 1.1 miles per hour with a min-max range of 0.5, and the results at the result had higher wind speeds with an average of 2.4 and a range of 1.7. So the conclusion that we can make is that the wind speed in Namkhatin is very average, and this can help disperse pollen as well as many other stuff for Namkhatin Park, and hence it can increase the biodiversity of the forest. As for errors, with a digital device, a mistake could have occurred. A mistake that could have occurred is very unlikely, but we can't take that for granted, and a failure of measuring device can still occur. Another error that can potentially occur is a misuse of the device by the user. For clarity, it can be the device is placed incorrectly, or there are other positions that the device was meant to be put on.
So now we'll move to the biomass, plant biomass, pH, and minerals contents. And here's the materials that we need to do this experiment. First, different species of plant. Second, a paper bag. Third, transparent sheet. Our purpose to do this experiment is to assess the ecological status of the site and the condition of the ecosystem in Namkhatin. And here's our results that we have collected. We have divided into 4 different tables. The first table on the left-hand side shows the real value of 3 different samples: wood, leaves, and mango. Next table at the bottom is about the weight after try first time, 10 minutes, after try second time, 20 minutes. And on the right-hand side, you can see 2 different tables. The first one will be about the conversion factor of 3 samples. And then we come up with the average conversion with 0.847. The last table is about the total solid weight and the moisture of 3 samples. To calculate the solid weight, we take the weight tri-pen with a tri-sample minus for the weight tri-pen time for 100, and then divide for the weight sample. To calculate the moisture, we take 100 minus for weight tri-pen with tri-sample minus for weight tri-pen, and then divide for the weight sample, and then time for 100. And here's the pH of soil in Namkhatin. pH is green. It gives us the results of neutral 7 for the first time, alkaline 7.5 for the second, neutral 7 for the third and the fourth time. or potash red. In the first sample, it gave us the adequate K2, and for the second and the third time, we got the same result. However, on the fourth time, it is deficient K1. Here's the analyzed results of our data. There are 0.65, that's mean of the fresh weight in that sample is 65% of it is dry weight and only 35% of it is moisture that has been removed through the drying process. There are going to be different type of moisture, and then we will come up with an average value of dry weight, which was 84.7%. Species differ in the amount of plant moisture that they can retain, and dependent on the time of year, some plants might actively grow and have more moisture than other plant species. Conversion factor must be determined by species. Conclusion. We could know that each sample will have different biomass which provide value information about the productivity and health of plant populations and ecosystem and how they respond to environmental changes. Here's our last experiment, which is catching small motile animals and squid net. Our purpose in this experiment is to know how water conditions in Namgat Park will help organisms, especially the phytoplankton, to grow. Here is our result through the microscope. As you can see, there are some small phytoplankton in the water that we have collected. However, all of it have died because there are no oxygen in the container. Phytoplankton can survive in a wide range of pH level, but they would prefer slightly alkaline condition with a pH between 7.5 and 8.5. However, the pH that we have collected from the water is 9.5, so it is not a suitable conditions for the phytoplankton to grow and thrive. Most phytoplankton thrive in water temperature between 10 to 25 degrees Celsius, while the temperature of this river is 27.6 degrees Celsius, which is not a good condition for it to survive. And here's the conclusions for our experiment. The water here is not so polluted for organisms to survive, and the ability of phytoplankton can survive and thrive will depend on the type of pollutions, the concentration of pollutions, and the duration of exposure. Pollution could create a dead zone in water where organisms can survive. The error that we have made in this experiment is we are a little bit careless when we forget to let the oxygen in the cap, so all of the phytoplankton has died. Lastly, this is the link cited for our presentations.